Hello everyone, welcome back for another lesson. So we will continue talking about mechanical functions, and in this case we'll talk about more specifically guiding control and adhesion and friction, which is kind of the opposite of lubrication. So let's begin. So guiding control. So a guiding component or a control, it's a component whose mechanical function is to guide the motion of the moving parts. So it says it's guiding or controlling the movement of the parts. Now, an object can move or a part can move along an axis or around an axis. We know there are three axes, X, Y, and Z. And we know there can be translation and rotation. So that means 2 times 3, there can be 6 different types of motion, what we call degrees of freedom. Okay, so a degree of freedom or degrees of freedom are possibilities of independent motion. So objects can translate and rotate along or around 3 axes, so that gives us 6 degrees of freedom. So minimum 1, maximum 6. We will take a look at examples. All right, so there are types of guiding, right? So there's types of movements. The first one is translational guiding. So we have here the drawer, and we have that component here that guides the drawer in and out. So this is a translation. The drawer can only go in and out, only translation in one direction. So this would have 1 degree of freedom, and it's translation. Okay, so translational guiding ensures the straight translation motion of a moving part. Rotational guiding ensures the rotational motion of a moving part. If we take a look at the wheel, for example, the wheel can only turn in one direction. So again, 1 degree of freedom. In this case, it's a rotation around the axes that would be perpendicular to it, so kind of in this direction. Then we have helical guiding. So a helical movement is a mixture of a translation and a rotation at the same time. Here we have a C-clamp. Don't know if you've ever seen this, but basically it would open from this end and you can put an object in the middle here and secure it. How do you open and close this section here? Well, you're turning this. You can see it looks like a screw. So you're turning this part, and as you're turning it, so it's a rotation, right? As you're turning it, the whole thing goes down or goes up, depending if you're turning clockwise or counterclockwise. So it translates up and down, but it translates because you're rotating this component over here. It's one part. So because it's rotating and translating at the same time, we call this helical. And the guiding component is this little section over here. So this is hollow. That screw goes through. So that component here forces the screw to go up and down while turning on itself. Okay, so this would be the guiding control over here for helical guiding. So 3 types of guiding: translational, rotational, and helical. Then we have adhesion and friction, which I said is the opposite of lubrication. So adhesion is the phenomenon by which 2 surfaces tend to remain in contact with each other without slipping. In mechanics, friction is a force that resists the slipping of one part over another. If you have shoes on, the sole is made of rubber, you try to slide, you can't, right? Even if you try to slide on ceramics or wood or anything, you can't, because there is friction and there is adhesion. So the surfaces are in contact, they don't want to slip, and there's a force that's preventing you also from slipping. Lubrication is the opposite. It's the mechanical function performed by any component that reduces the friction between 2 parts. So sometimes you don't want the parts to stick together, to have friction. You want to reduce that. So you're going to add lubrication so the parts move together more easily. Now, what kind of lubricants do we use? It could be oil. So that would be a liquid type. Semi-solid would be fat from an animal, like bacon fat. And solid, well, it says it's solid, would be wax, for example. So those are the different types of lubricants we may use to reduce friction and adhesion. Now, there are 5 factors that affect adhesion. So the nature of the materials, so depending on what's rubbing together, rubber on asphalt, for example, there's good adhesion. That's why tires are made of rubber, right? So the nature of the materials, some will slip on one another more easily than others. Is there a presence of a lubricant or not? So oil or wax or whatnot. The temperature. Now, when the temperatures are colder, there's less adhesion. That's why we say in the winter, we have to be more careful when we drive because the tires do not adhere to the ground, to the surface of the road as well. So we can slip more easily. Notwithstanding, maybe there is ice on the road as well. The surfaces, are they rough or smooth? If the surfaces are very smooth, there's going to be much more slippage. If they're rough, and that's why the soles of our shoes have grooves, right? If the surfaces are rough, there's going to be more adhesion, less slippage. And then the last one is the mass of the object. A heavy object will have better adhesion and more friction. So a heavy car versus a light car, for example. A heavy car will because of gravity, adhere to the ground much more than a lighter one. So those are the 5 factors affecting adhesion. The nature of the materials, the presence or absence of a lubricant, the temperature, warm is better if you want things to adhere together, the type of surface, and the mass of the object. So that's it for this lesson. I hope it was clear. If you have questions, don't be shy and pose your questions. And otherwise, I'll see you for your next lesson. And until then, take care.